Hello everyone, my name is Thai Ngan Do, a student of Professor Ji Kim from Intelligent and Process System Engineering Lab, Songkyung-won University. Today I would like to present to you a topic optimization-based framework for technical, economics, and environmental performance assessment of CO2 utilization strategy. Firstly, please take a look on the industrial use of CO2 estimate for 2020 and 2030. There is imbalance of supply and demand, a huge potential CO2 from a large source emission, while there only a small portion of CO2 has been industrially utilized. Although a high rate of CO2 were estimated for sequestration underground and utilization for CO2-based materials, a large potential surplus of CO2 for CO2-based fuel or energy product thus can be shared burden on conventional energy sources. In this work, we firstly develop CO2 to energy fuel CCU4E framework with different CO2 utilization technology like catalyst conversion, thermochemical energizing, electrochemical reduction for various liquid fuel. We also developed the optimization-based framework for CO2 utilization strategy to identify and analyze CO2 to fuel with different evaluation criteria like energy efficiency, product quantity, product cost, or net CO2 emission. And then the techno-economics and environmental performance with different conventional and renewable resource input were examined. The goal of this study is to propose an optimization-based assessment framework for establishing CO2 utilization strategy for target CO2-based fuel. The proposed works involve the steps as follows. Step 1. Set up the problem by choosing captured CO2 as a main feedstock, choosing possible technologies and final product, and generating superstructure by integrating technology for target product from CO2. Step 2. Develop a process simulation of every single technology and technological pathway for technical data like mass and energy balance, also economic data, estimation of cost and sizing. Step 3. Develop an optimization model for decision making with generated data and associated parameters. Step 4. Identification of an optimal solution for a given problem based on a specific criterion like energies or cost or environmental effect. CCU4E superstructure were developed by interconnecting multiple technologies for dissolved fuel. CCU4E involved 4 types of compound and various technology. Superstructure starting from CO2 utilization technologies and following by upgrading process, separation and purification for dissolved fuel. Notably, technology consists of various equipment for its operation purpose, like reaction kinetics expression, temperature, pressures. Then the process simulation of each unit was simulated using Aspen Plus. As you can see in the table is the simplified process flow diagram and description for main technology. Sizing and costing data were obtained and estimated for further technical, economics, and environmental evaluation. This work considers various criteria as objective function to determine the best CO2 utilization strategy for each fuel. Then we develop optimization for 4 different objective functions regarding to energy efficiency, product quantities and product cost, and net CO2 emission. As you can see here is a 4 objective function and model for the formulation for is The constraints of feedstock availabilities and minimum purchase, that is the feedstock purchase with upper bound of the minimum purchase and lower bound by feed availability. Also, the constraint is constrained by demand sacrification. As you can see in the tables, is the result of optimization framework. For example, the optimized strategy for methanol with different criteria. The optimal CO2 to methanol strategy regarding to maximum energy efficiency improve pathway of thermochemical energizing. The first one, following by methanol synthesis. However, its UPC is around 5 times higher than the other. The most economic and eco-friendly strategy is the direct CO2 hydrogenation, and its value shown in the table. Similarly, the optimal strategy for DME product within various criteria also shows in the below table. For the optimal CO2 to FT fuel strategy, the direct CO2 hydrogenation to FT fuel is outstanding strategy, which is the optimal one for all 4 exam criteria. At the same time, the table below also shows the strategy, the optimal strategy. The optimal values depend on the criteria were sold for the gasoline from CO2 feedstock. In conclusion, we develop optimization-based assessment framework for CO2 to fuel strategies, which includes a number of conversion and separation technology for a desired fuel production. The optimization-based assessment framework enables us to identify CO2 utilization strategy for different fuel productions regarding to various criteria. It also supports the policymaker and stakeholder in identifying suitable strategic solution in utilizing CO2 for fuel. Thank you very much for your attention.